There we go. Didn't have the thing. Now, I didn't explicitly write it in the initial directions there, but remember that writing a function rule means you also define your variables. It's not enough just to toss y and x up there and hope that people know what you mean. Okay? Define your variables. It's also what allows us to use whatever variables we want. I also believe that a cookie should be at least 50% chocolate chips. Well done. Okay. Okay. Write your function rule. Label what your variables mean. Then use it to answer the question below. You can't go straight for the throat and just answer the question by doing some mental math and basic arithmetic. We need to know how to write the function too. Regular or extra crispy?
Extra crispy.
Okay. 7 or 9? Do you write too hard and break lead?
No.
Then 7. Little tip for you if you're one of those kids that's always breaking your lead and writing too hard because you're going to mutilate your paper. You're sniffing down the right trail. That's all I can give you. You're not there, but you're pointed down the right trail. No, this one is not graph. Now, we could graph this function once we have it, but you don't have to right now. Just write the rule. Write the equation. An equation is just a relationship. Input, output. Doing this controls that. You're lucky I'm fluent in mushmouth. Remember, we're doing stuff together in class. By all means, chat it up, argue, have fun. It's got numbers in it. Yeah. This one is linear, yes. I'll give you that much. This one is linear. We were writing function rules for both linear and nonlinear last time. I'm going to put the linear one on the daily quiz because that's the one we have to know. Nonlinear is tougher. You'll get plenty of experience with that over the next 3.5 years. Okay, right now we're just training wheels. Love it.
Yeah,
Love it.
completely over the head.
Love it.
I've fallen asleep in every single one of my classes today. Don't expect me to understand anything.
Well, as long as you make it up eventually, I understand. Right now I am held up purely by caffeine and spite. So, all right, that's a lot of time. Shouldn't take too long unless we're struggling through puzzling it out. Okay, if we don't got it by now, well, it means we just don't know how to do it. What are the two things you're talking about? Money, and so how much you borrowed and how much you pay, right? So which one depends on which? Does the money you borrow depend on what you're going to pay back, or does how much you're going to pay back depend on how much you borrowed? Okay. So we've got how much I borrow determines how much I have to pay. Now you can label your variables whatever you want. You can call it X, Y, B, and P. I don't recommend that because dyslexia exists. But how much you borrow, how much you're going to have to pay, I'm cool with that as just X and Y, but make sure that you label what they are. Then, the amount I will have to pay is, what do you got to pay back your sister no matter what? The $9. To even have access to my funds, you got to buy me lunch. And then the rate. The rate for how much I borrow is 20%. And yes, there is, if y'all remember, that's decimal to percent. Percent to decimal is always two places. Okay. I always like doing this one because it shows you which way to go, depending which one you're going to. We have a percent. We want to go to a decimal. So I'm going to move it two places to the left and say this is 0.20x. Okay. Another way to do this was, because it was linear, we wrote that down a few times, rate x plus start. I start having to pay back $9, buy her lunch, and then my rate was 20%. Okay, round two, how much are you going to have to pay extra if you're borrowing 40 bucks? So now I'll say 20% of 40 plus 9. 20% of 40 is 1/5 of 40, or $8. $8 plus 9 is 17 bucks. Or you could just jam it one shot in your calculator. Okay. Now, see an awful lot of pens and pencils going. A reminder, if you're writing down what the correct answer is next to yours, that's one thing. If you get done doing the problem and then look to your neighbor and double check and don't change yours, that's one thing. The second that you start changing your work, based on what your neighbor had or what I wrote up here, you are giving yourself a false sense of security. Remember that the daily quiz is just supposed to be a gut check. It's supposed to be C-level, middle of the road. You should know how to do this. It's only worth 10% for the entire year. So if you are falsifying these, if that isn't actually what you had, then that 4 or 5 every day on a daily quiz doesn't matter compared to the 61 you got on the test. Okay? Those are where the big money is. So if you didn't do so hot on this, you're not gaming the system by scribbling this out and putting this instead, erasing this part and putting that instead. That I actually got a 3 out of 5, I actually got a 2 out of 5, I barely wrote numbers. That tells you need to ask questions. Okay?
Did you have to pay for the original amount that you borrowed as well? Oh, never mind.
Okay, now that's a good question because that is in the wording of it. How much extra will I have to pay? 17 bucks. If I was talking about how much will I pay total, what would be different?
It'd be 1.2.
1.2, because you have 100% of the money you borrowed plus another 20%. Is there anyone who did that? Anyone who had 1.20x plus 9 and then 1.20 40 plus 9 is 6 fifths, 5, 8, 48, 9, $57? Like that's exactly what you had, orange stuff?
Yeah.
Okay. So what I would do if I saw a kid do that on a test, and then I'd give you full credit. Okay, now on a final, I'm going to take one off. But it's obvious you know what you're doing. We just missed the word extra. Okay? So for today, you're cool. Future, watch out. You should have the rate as a decimal, the starting amount. The end amount, I'm not going to put further work for that because you might have just mental mathed it, honestly. Did you label your variables? That is the important part. And then, okay, so this was for having the rate. I'm going to leave one as a floater for, maybe you accidentally called it 0.02. Like you tried to do the thing, but you called it 0.02 instead of 0.2. You had all this ready to roll. You had 0.2, you had 9, you put the X over here because brain fart. Okay, that's also going to domino effect into here. I like to leave, if at all possible, one floating for the, I did all that, I just, oops. Those are the 4 out of 5s. Okay? Anything about it? Cool. Then you go away. Save. Safe. All right, from the homie work. I don't remember getting any questions. Maybe one. Hey, you asked me something, right? Yeah. What do you got?
Start with number 19.
Okay. 19. Do I got... Write a rule. Area of a triangle with a base 3 centimeters greater than 5 times its height. Okay. So round 1, I hear area of a triangle. I'm going to look up area of a triangle. I'll write that. Then I'll start replacing things. It says the base is 3 centimeters greater than. The word then tells me I'm going to add it on the end of 5 times the height. 3 greater than 5 times the height. Now that I know B is this stuff, I will replace B with this stuff. 1/2, not base, 5h plus 3, height. Just replace it. This is kind of foreshadowing systems. I don't know how much of systems you do in middle school, where I say, why is this stuff and why is that stuff? So I can cut out the middleman and say this stuff equals that stuff. Okay, it's also called a transitive property. You'll do more of that in geometry. It's a way to mix and match when I have too many variables. What is the area of the triangle when its height is 6? Now, I could leave it like this. I would prefer, if at all possible, we clean it up. 1/2 times that stuff and h times that stuff. Distribute from both sides. Area is 5/2 h squared plus 3/2 h. You can distribute it all at once or you can do it one at a time. That's where it's going to end up. And then, what is the area of the triangle when its height is 6? 5/2, 6 squared plus 3/2, 6. Getting 36/2, 25, 5, 90, 96, 12, 18, 108, I think. Labels matter. What would a label be on this? Squared because it's area. Centimeters because they said it in the problem. Squared because it's area. I mean, centimeters is how far. Centimeters squares, how many squares fit in this object. Cubed, how many cubes will fit in this object. At least that's kind of how I always remembered it. Okay, besides 19? Anyone besides?
I looked on my calculator and it said it's 99.
99? 6 squared is 36. 36 half is that is 90. So. Because I just plain didn't divide by 2. See? Brain fart. I didn't put the question mark next to it, so yeah. See, I did mental math, and I shouldn't have. I should have qualified it with a question mark on there to save myself, but you got me. Okay. All right. Come on now. Then we should be able to. I'm pretty sure we'll be able to. Now, if I remember right, we blanked here and we put like a bucket or a candle or something over here, whatever we were working on. So you still got room over here for all of your function stuff. I don't do vocabulary too often. I'm definitely not going to put vocabulary on a quiz or a test. You're not going to have matching or fill in the blank or anything like that because everything's open notes. But I do expect that you're going to know what the vocabulary means because you've all run across a problem where they use big math words and you have no idea what they're even asking you. Okay? You got to know the vocabulary to understand what they're asking you to do. Like, people use big words and it scares folks. Okay? Like a primary example would be someone starts complaining about the kids in the bathroom over there because they're doing dumb things. And I'll say, yeah, well, there's more than one pandemic going on right now. There's also rectocranial inversion. And you use big words, and if you don't understand what the big words mean, break it down Recta, cranial, inversion. Anyone? Rectum, cranium, inversion. There you go. It's a really big vocabulary word of saying, yo, you got your head up your butt. Okay? These are words that if you have never seen them in context, if you don't write down the definition, if you don't know what they mean, what happens when they're in the instructions of a problem? Okay? If someone uses big words, you don't know if they're insulting you or not, unless you know big words. If someone uses correct vocabulary in a problem, in the directions of the problem, and you don't know what it means, you're kind of toast. So, it's one of the few times that we're going to write down vocabulary here. A relation. What?
I don't have to get 6.
Packet. Did I put the packets back there? Should be.
Yeah.
Right? Yep.
Yeah.
Here's the back half. Remember, there's I thought I printed the entire thing, but I only printed half of it. All right. A relation. We've talked about it a little bit. A relation is a mapping or rule that sends my inputs to my outputs. Okay? Think about if someone says, what was it? Grace, you said you had a sister who was in here for like 2 days and I didn't know them, right? Emily? Was it Emily? No? I thought you said you had a sister in here. But it's not often, or it's not uncommon that a kid will come into my classroom and I ask, what is your relation to so-and-so? Okay. Bailey. I recognize the last name. What is your relation to Jackson? Okay, that's your brother. I don't know if that's your brother. Is that your cousin? Uncle? Okay. You never know, right? So I'm just asking, what is the relation? The relation is, what is the rule that maps you to that person? It is the brother relation. Okay? The rule is, you share at least one of the same parents. Makes brother. Okay? A function is a very special type of relation where you map, MP, pretty sure there's an A in there somewhere. You map every input to exactly one output. Every input has to have one output. Not 2, not 5, 1. So, an example would be, who in here's got multiple siblings? Okay, so I say, this is the sibling machine. I throw Sailor into the sibling machine. Out spits siblings. Okay, however many of them there are, you had multiple outputs. Sailor's the input, those are the outputs. Who has exactly 1? Okay, I throw Dominic into the machine and only 1 comes out. Maybe think of it as an actual machine. Every button that you press is only supposed to do one thing. I press the Mountain Dew button on the pop machine, boom, here comes the Mountain Dew, assuming that I'm paying for it. I press that same button again. If it spits out a Cherry Coke, that machine broken. It's not functional. It's not doing what it's supposed to. That one input was supposed to have exactly one output. If I lay on my horn to let the guy in front of me know he needs to rethink his life choices, and it makes a sound, and then I lay on the horn again, it should make the same sound, input to output. But if I lay on the horn again and instead my windshield wipers start flapping, it's not doing what it's supposed to. The input had too many outputs. The way that you should see this is if I have a bunch of inputs and outputs, say these are the possible buttons on the machine, those are the possible results of the buttons. Then a relation could do this. As long as it maps input to output, you're good. A function says, you go here, you go here, you go here. Every one of my inputs went to only one output. It didn't go to multiple. So every time it split V'd like that, that's not allowed in a function. That says, I'm pressing the volume button and the volume goes up. I press the volume button again and it turned the TV off. It is not a functional machine. Okay? Now, those inputs and outputs are going to have special names. They are domain is the inputs of a relation, and range is the outputs of a relation. And if we need to add next to that, the inputs of a relation are my independent variable, which is usually my x's. My outputs are my dependent, which is usually my y's. And one of you had said this, was it last class or last week? Someone said this really well. The independent is what you control. The dependent is the result. I can pick the x and then find the y that goes with it. I control what number I'm putting in. And then it spits out something based on the rule, based on the mapping. Okay? I can't stress enough how important these 4 words are. You're going to see these 4 words for the next 4 years. Okay? They're super, super important because you'll be bogged down in just, say you're in geometry and you're working with parallel lines and transversals, you're starting to do proofs, and then out of nowhere, left field, they say, prove why every element of the domain is maps to one element of the range for this particular set of vertices. You're like, that's a bunch of big words. I know I've heard domain and range before, no ding ding, but I don't remember what they mean. Okay? These words are super, super important. So, see it in action. Domain and range. Said domain is the inputs, which is usually the x's. So if I've got a whole bunch of coordinates, domain is very simply list all the x's. And we're going to use these squiggle brackets. Remember sets from last semester? Squiggle bracket, -2, 0, 4, 5. Range is going to be all of my y's. Again, squiggle bracket to say it's a set of things. 0.5, 2.5, 6.5, uh-oh, 2.5 again. If I ask, someone asks, which game club kids were in your room today? Dominic shows up for lunch and I smack him around in a game of Magic. Dominic comes back for class. Do I say Dominic twice? Or do I just say Dominic was in my room? Okay. I end it right there. I don't say 2.5 twice. It happened twice. He was in my room twice. I don't have to say his name twice. Okay? Amy pops in this morning, asks a question real quick. Comes back for class later. I don't say Amy twice. Okay? And then represent it with a mapping diagram. The mapping diagram is, you're going to make this domain and range, and you're going to list out, here's all of my domain, -2, 0, 4, 5. Here's all of my range, 0.5, 2.5, 6.5. And the mapping, it's kind of like if you've ever done custom mapping on a controller. You're saying triangle does reload. Second shoulder does alt fire. You are saying this will do this thing. -2 will go to 0.5. 0 will go to 2.5. 4 will go to 6.5, and 5 will also go to 2.5. You ever got a game that just doesn't have as many different operations or commands? So maybe both of your bottom shoulder buttons are both alt fire. Okay. You can have more than one button do the same thing as long as they are each doing one thing. That would really suck if I'm like, oh, big crew, M40, bam. All right, I'm gonna do it again. And I jump. You did, right? I want this button to do one thing and that button to do one thing, but they are allowed to do the same thing. Is it a function? Is every one of these going to one place? They're allowed to go to the same place, but they are each doing one thing, yes. So I will say this is a function. Okay, do that all again. So my domain, x's, 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 x's. Squiggle brackets, x is 4, 5, and 6. Someone usually asks, do I have to put those in order? No. It's considered beneficial if you do. Okay. Just if I do things in a certain order, it typically benefits me and makes things easier later. My green. There we go. Range. Range, 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 range. So I've got 3, 4, 5, 8. My mapping. Is going to be all of my domain, all of my range. I list them. 4, 5, 6. Where'd it go? 3, 4, 5, 8. And then, kind of like you're playing Among Us, right? You're just trying to get the wires crossed to where they're supposed to be. You say 4 goes to 3. Check. 5 goes to 8. Check. 6 goes to 5. Check. But 6 also goes to 4. Okay? You're just drawing a line and saying this goes here, that goes there. This is what it does. And then, is that a function? Does every blue button only do one thing? Or do any of them do more than one thing? Who's the culprit? 6. 6 is bad news. 6 went here and here. It went to two different places. That's not allowed. So I will say not a function. Now it is still a relation. A relation just maps things. Relation says this goes here, that goes there, that goes there. That is a mapping of a relation. It's just not a special relation, not a function. Okay? I'll leave that right there so you got something to riff off of, but you still have what's in front of you anyway. Down at the bottom, A and B. Tell me the domain, tell me the range. Yes, ma'am.
Why do you have the parentheses there at all?
The parentheses. The little squiggle brackets on the sets. These? The other one. Up here? Oh, it's a set of coordinates. The squiggle bracket says this is a set. It's a collection or a group. And then each of the coordinates goes in parentheses. So it's kind of like sometimes you'll have one box that's got a bunch of other little boxes in it. The squiggle brackets are the big box. The parentheses are all the little boxes that came in the giant Amazon box. Okay?
So
Yeah.
now if there are two X's.
Only if they go to different places. Remember, I can press the volume up button and then press the volume up button again. So long as the volume went up both times, it's good. For example, okay, this was 6.5. If this was 6.5 again, it would have been fine.
So if I'm not going to see places.
Exactly. Basically, it's if I see this, that's okay. But if I see this, that's bad. Right? More than one button doing the same thing versus one button doing too many things. I had a kid, was it last year, I think, just came up with that as just the quickest way to say whether it works or not. It was beautiful in its simplicity. Draw those arrows and they tell you whether it's a function or not. Okay? Bottom, A and B. Right, remember, daily quizzes, you quiet. These, go ahead and chat with your neighbors. Make sure that you're doing the same thing. You got it drawn the same way. I know we got several in here who are artistes. Go ahead and make your mapping fancy. Make your mapping fancy instead of just scribbling it down. Okay? Lean into it. I had one guy years ago who drew like little stick figures with cannons shooting at the different elements of the range. Go for it. Yeah, it did. But it was cool. Huh. That ain't good. Okay. Got them. Remember, it's not just list the domain and range. You have to have the mapping that goes with it. That little box with your lines drawn. 2 goes to this, 3 goes to that. We chatted more about this. We said, see how this one, -2 goes to a place, 0 goes to a place, 4 goes to a place. The mapping, because they're the coordinates. -2 goes with 0.5. It's kind of like, who's dating who? -2 is dating this one. 0 is dating that one. Every case, they're only dating one thing. These two happen to be dating the same person. Awkward, but it works. This one, you can't be dating 2 different people. Or at least in a monogamous society. Okay? Oh yeah, if you're poly, go for it. But that would be, so these are functions, because everything went to one output. This was not a function, because you had a button that went 2 different places. You pressed the button and it unlocked your car, you pressed the button again and the horn started honking. Right? The button didn't do what it was supposed to the second time.
Also, do we have to use fractions in these? Like, not these, but like in graphing, because I do not know how to do fractions.
Eventually. Yes. And what I tell kids is I will definitely work on fractions with you, but get yourself a good scientific calculator. Get yourself a good scientific, okay? The Casio, Grace, you hold up yours. Those are like 10 bucks at Walmart. These ones are 18, and I have sworn by them for like 12 years now. The one that Killian's got. The one that Keely's got, I think those are only like 9, 10 bucks. Same thing, and they will all do amazing fraction stuff for you. I want you to focus on the algebra. Let the calculator do the heavy lifting. Then you ask lots of questions. Then we ask lots of questions. Okay. Okay. First one. I'm going to cheat here and say if I'm stating what my domain and range are, you notice in our mapping boxes we said domain, this stuff, range, this stuff. Call it good. I'm going to say this is my domain, X's. 4.2, 5, 7. Ah, crap, Dominic came back again. I don't say Dominic again. I don't put 4.2 again. I just say, yeah, he was here. Range is all of the Y's. So I'll list, here's my range. Where's my smallest one? 0, 1.5, 2.2, 4.8. Now, Amy's kind of, you're headed down the right trail here. Notice how I got more outputs than I do inputs? More X's than Y's? The only way that I'm going to get to all of those Y's is if one of my X's goes to 2 places. So that means it's probably not a function. So I say 4.2 goes to 1.5. 5 goes to 2.2. 7 goes to 4.8. 4.2 goes to 0. And again, you got that split off V going in 2 different places. So I would call this, on a daily quiz, you labeled your domain, you labeled your range, you put the mapping in there, and now you tell me, is it a function or not? And I'd say, not a function. If it asks you to explain why it is, you would tell me 4.2 maps to two values. Okay. 4.2 is shacking up with two different outputs. Okay, not cool. Round 2, turbo version. Domain, range. Domain is all my x's, -2, -1, 4, 7. Range, all of my y's, -7, -4, 1, 2. Mapping, -2 goes to 2, -1 goes to 1, 4 goes to -4, 7 goes to -7. They all kind of cat's cradle in the middle, but is each of the inputs, each of the domain, going to one place, not two places? So that's a function. Kind of like which of you has the rat's nest of wires behind your TV? Like, if you had to unhook the Blu-ray player, it's going to be a 20-minute adventure. But is it going to one place? Yeah. So it's a functional machine. Okay? Who's the neat freak that's got all the little Velcro cable ties? Got to do it, man. Okay. Vertical line test. You hear about this in middle school? I don't know.
I think so.
Maybe called the pencil test for whether something's a function or not. Okay. So, part A is graph the thing. Plot your points. If you need to remember x, y, x's go this way, y's go this way. Plot all your coordinates. First one is left 4 and up 2. Second one is left 3 and up 1. Third one is no left or right, down 2. I'll do brown. Okay. -4, -1 is back 4, down 1. Can y'all see that? I feel like that's not the best color. You can see it? Here. Let's switch over. And what else have I used? Green? Green. Right 1, up 2. Okay, the vertical line test says put your pencil on there. Like, colors? Blue. There we go. Put your pencil or your straight edge, your ID, your whatever, as a vertical line on the graph and just drag it across the graph. Oh, you mother. These are all going to be off now. Actually, that ain't bad. Okay. No, no, no. Okay. Try this again. Okay, now I'm really mad. And then we sneeze. All right. Grab the line. Stop. Why are you not grabbing the line? I'm trying to be all pretty and color coordinated here, and Frank's being stupid. All right. and 4, 2, and 4, 1, and 3, 1, 0, 2, and 4, and 1, 1, 2. There it is. Poke. Okay, there we go. I have the line. Move your vertical line across the page. Does it ever hit more than one point? Assuming I drew a straight line instead of an angry curved line, yes. It has failed the vertical line test. The vertical line test says, I just chose x equals -4, and it spit out a 2 and a -1. Right? -4 mapped to both 2 and -1. That button did two things. It's not supposed to do two things. It's supposed to do one thing. So the vertical line test is a really quick way to just throw your pencil on your paper and nope, not a function. Hits it twice. Okay? Now this one they gave me coordinates. The other one they did not. So how am I going to graph something that they did not give me coordinates? Make coordinates. Make the table. Off to the side. Choose your X's and your Y's. I don't see any words associated with it, so I'm just going to pick numbers right smack in the middle of the graph. -3, -2, -1, 0, 1, 2, 3. Blue. Y'all got your calculator, get some mojo on. Fill in your table. Remember, everywhere there's an X, you're plugging one of these numbers in. You're saying negative thing squared plus 3. Grab a calculator. Negative, parenthesis, -3, parentheses squared plus 3. Enter. I'm not going to force you to show all the work for it if you can calculate her well enough. Okay, I'm not big on the you must do it by blood and stone the way we did in the ancient times. Like, y'all got a calculator, use it. But you do have to use parentheses. That is very important. Parentheses keep us from screwing up negatives and exponents. Yeah.
I need to know if I'm just doing this the hard way, but is there a back button that I'm not seeing?
Back.
Ah, thank you.
Yes, sir. Okay. You're supposed to have the fastest thumbs of any generation before you. Typey, typey. Okay? So you fill in those points. And say, at 0, we got 3, 2, 2, 4, -1, -1, 9. It's -6, -6. Okay. So you fill in your table, plot your points. Whatever you can fit on there, fit it on there. Say at 0, 3, poke, poke. 1, 2, 3, 4, 5. Oh, so close. We'll go off-road a little bit. Okay. Plot your points. And we talked about this whole continuous and discrete thing. Continuous means I'm allowed to put fractions in there. Discrete was I can't have a fraction. So examples were like, I can't buy 2/3 of a couch. You got to buy the whole couch. Okay? Am I allowed to put 2/3 in for X? There's no word problem. There's no word context with it. So yes, which means I'm allowed to connect the dots. But actually hit the dots. That last one was bad. Okay? Shh. Don't judge my drawing. Okay? Now that I'm here, vertical line test. Get your pencil or your straight edge or whatever it is. Oh. Yeah. And move it across the paper. Do you ever hit this graph more than once on that vertical line? No. So it passes the test. This is a function. If it hits it twice, not a function. Hits it once, it's a function. Okay? So this one is a function, and if they ask you to explain why, you say it passes the vertical line test. Vertical line test is going to get used a lot throughout high school. We're doing ACT review after school here in a little bit. I'm going to have kids who probably haven't had math in a year and a half coming in like, oh crap, I need to take an ACT to go to college. And we're going to say, do you remember vertical line test when we come across a certain question? They'll be like, hey, I remember that guy, because they've done it 50 billion times. Vertical line test is going to happen a lot. So, if that is how it's done, show me that you can do it. Both are just coordinates. I wanted to have one up there that had just the equation instead of the coordinates instead. Plot your points, vertical line test. Is it a function? Yes or no? Okay. Plot all your points for A, plot all your points for B. Throw your pencil on there and move it across the paper. Say, does it work? Huh? You know how to plot points.
I know. It's
I understand that. But if I have to, you have to.
I fell asleep on the bus this morning. Like it was that much of a day.
I was first on and last off of an hour and a half, 2-hour ride every day.
I'm last on.
Yep. And be times where Raleigh would pull into his yard and start sweeping out the back of the bus, and he'd find me passed out in the back seat.
Say, I can't right. What happened to X here can happen to basically Y here, right?
What do you mean, what happened to X?
There wasn't the number popped up twice.
Oh, yep. So just plot your points, right? 4, 2, 1, 2, 0, no left or right, 1, -2, 2, and 3, 3. 1 to 3, 1 to 3. Now, go across, and does it ever hit more than one point?
No.
So it's a function. You don't even need this part. That's all it is. Plot the points and do the test.
I see.
You. No, not you. You. Okay. Plot the points. Tell me if it works or not.
For the line test, I haven't done it in a long time. I forgot.
Okay.
What?
So this one, see how I had a full equation? So I fill in the dots. This one's just got coordinates. I don't need to fill in the dots. It's just those spots. And then, what's this? 3, 3, 4, 2. This one should be over here. Okay. All right, and then hits it once. 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 Only ever hit it once. So it's a function.
Oh, but this one. Okay, yeah.
There you go. Yes, sir.
Would this one be considered a function because every single one is the...
Can you have a pop machine where every button on it is a Mountain Dew?
Yeah.
Yeah, I've seen them. Yeah, same.
So if it's functional, do you do the line?
Vertical line.
No, not that line. The line.
Oh, no. We did that because it was an equation.
Oh.
So I connect the dots because in between here and here, I could have put a negative 0.29. So I fill in all the dots. These are just coordinates. So I only make dots and nothing else. Yeah.
Sweet. Thank you.
No. Yeah. Turbo. 4, 2, 1, 2, 0, 1, negative 2, 2, 3, 3. If I have a vertical line and move that, hits it once, hits it once, hits it once, hits it once, hits it once. It never hit it more than once on a vertical line. So this guy, I would say it's a function. It passes the vertical line test. Contestant 2, 0, 2, 1, negative 1, negative 1, 4, 0, negative 3, 2, 1. You run across and say, only hits it once. Crud. Hits it twice. Because it hit it twice on one vertical line, now I'm going to say that this is not a function. It fails the vertical line test. Okay? We don't need an essay. You just say, nope, failed. Yep, passed. That's all you need. Talk to me, Goose. Show me thumbs. Like, I get this. This is solid. A little fuzzy. I should probably do one more to be safe. Or, dude, what? All feeling pretty solid? Maybe one more to be safe. Which ones are tougher, the coordinate ones or the graph ones? Either. Just try one of both. Just to be safe. I want to do those two. Just to be safe. I see some hesitancy. I'll do both those two. So for number 2, make the mapping again. List out the domain, list out the range, cross your wires. For 5, just do the pencil test. 5 should look kind of familiar. Y'all been talking about sinusoidal functions with physical science, right? Light waves, electromagnetic spectrum. Okay, was it Preston was asking me this one. Said, wait a second. You ever played an old retro game with a newer controller where you may have 6 buttons over here, but because it's an old game, all of them just do jump? Is it possible that they're all doing what they're supposed to, though? Yeah. So that is a function. As long as 3 is only going to one place and not 3 is also going to 6. That's bad. Here, if I draw a bunch of vertical lines across it, it's never going to hit it more than once. So that one is also a function. Both of them work. Okay. Womp. Poke, poke. 3 evaluating, 4, 5. Okay, so we're not going to get all the way, but we're going to get most of the way. Function notation. This is one of the times that I am most happy to have algebra half, because I have kids coming up to algebra 2, maybe all the way into pre-calc, and they've always been told f of x is just a fancy y. Someone tells them that right now, at this stage in their learning, f of x is just a fancy y. And they'll say, when you see function of x, it just means this. They're not completely wrong. They're not completely right either. Okay? See, you can talk about the same thing in different contexts. So maybe this is my aunt. This is also my guardian. In one context is sister of my biological parents. In the other context, she's basically my mom. Like, she performs all the duties that mom should do. She is mom, but she's not mom. You refer to the same person in different contexts, right? That's what's happening here. Function notation, you put a letter in front of parentheses x. F is the name of the function. And you can put whatever you want there. I could say g of x, h of x. You could have different variables in there. I could say h of t. That's one you'll see a lot. Height in terms of time. So this is the name of the function. Then we'll do parentheses and we'll tell you what the input variable is. The input variable goes here. This doesn't mean f times x because it's smashed up on it. This is its own notation. Okay, the input variable. So think of it more like name of input is the rule. Okay, this is the expression that tells me what I'm going to do with my input. Now, if I put something into a function, if I put something in for x, what do I get out every time? If you pick the x and then do math, what comes out? Every one of our tables. What do we do on the previous page? You picked x's, plugged them in, and found what? Y's. The name of my function, of my machine, is with all of these things, I'm going to do this to those things. And when I do, I will get out a y, an output. Where people will get confused with this, and a lot of Algebra 1, Algebra Half, pre-algebra teachers get really frustrated because this is the first time you're learning it and kids can't wrap their head around that idea, is they'll just get frustrated and say, it's just a fancy y. Like, no. It's a cause and effect thing. Have you ever heard cut out the middleman? Okay. If every Thursday is Throat Punch Thursday. Whenever Thomas wants to throat punch Thursday, he punches Preston. Two if-then statements. If throat punch Thursday, Thomas wants to punch people. If Thomas wants to punch people, he's going to punch Preston. What happens when I say, tomorrow is Thursday? Couldn't you just skip all the middleman and say, Tom's going to punch Preston? Okay? So what happens here is I can cut out the middleman and say, if the function of x is to do this with x and that gets me a y, the function of x is y. And that's why so many teachers get frustrated and just say, screw it, it's just y. They're talking about the same thing, but they're talking about it in a different context. This is a thumb, but it's also a phalange. It's also a finger. It's also a reload button. It's also a fly smasher. It's also a booger wiper. I got toddlers, okay? Like, it's still the same thing, but I'm talking about it in different contexts. Function notation is a fancier, more technical way to talk about what an equation does. Okay? So when they say w of x, w of x is 250x. What this tells me is w is the name of the function. Words in terms of x minutes is 250 times x minutes. Words in terms of minutes. Y'all done typing tests? Probably you're one of the first generations that you've had keyboarding since what? Second grade? Third? When do you remember I had to go to computer and learn to not look at my hands? About third, fifth? Okay. Depends on the school, depends on the teacher. Okay. I had keyboarding in high school and I dropped it after 2 days. I type amazingly with these 4, maybe 5 fingers. I don't know how to do the home row thing. Because day one, they had me play the Mario game where you press A and he jumps, and you press S and then he hops and he does the thing. And then the next day, they put a box over my hand so I couldn't look anymore. drop the class. No. I can do this in 1 minute. I can do this. Here's how we write it. How many words can you read in 8 minutes? My input just became 8. So I replace this with an 8. Okay? So the green is just what it means. You don't have to write all of this stuff. I just want you to really wrap your head around this notation. So I'll get kids all the way into Algebra 2 and they just don't understand this notation. All you have to say is W of 8 is, I will take 250 times 8. Okay? W is the name of the function. Words I can type in terms of X minutes. Now I'm saying the words I can type in 8 minutes is 250 times 8 minutes. It's simple when you think about it as just, well, yeah, I just multiply by 8. But you have to understand why it's being written that way, or else the whole thing's going to crap out on you later when we start giving you functions that look really gross. We got to get used to how it's written. So 254, 255, 2000. So what changes about this for this? What's the only thing that changes? 8 becomes a 6. So now I'm going to say W of 6. And that's how we say it too. W of X, W of 6 is to take 250 times whatever I just said, 6. Which is 1500. Did I just hear a walking Nerf? Well, nerds are cool, so yay. But a walking Nerf, like that sounds like someone had their stats downgraded. Sorry, you're going to stumble every 15th step now. So, I just do that, right? So, at the very beginning, we said domain is all the inputs. That last one, 8 and 6, were my inputs. The 2000 and the 1500 were the outputs. Go all the way back to the very first slide of this. What are the outputs called? What's their fancy name? Okay. Finding the range of a function means I'm going to take this and say the function of a thing is to do negative 1.5 times the thing plus 4. The function of a thing is to take negative 1.5 times the thing plus 4. That is the purpose of the machine. What is your function? Okay. This yellow stuff. This is Wally looking at Eve and saying, directive. Okay. Or no, it was the other way around. Eve asked Wally that. It's been a while since we've seen Wally. What is your directive? My directive is negative 1.5 times a thing plus 4. That is what I shall do with everything that I see. So, do it with a 1. Get your calculator mojo on. Negative 1.5 times 1. It's negative 1.5 plus 4. Plug in a 2. Plug in a 3. Plug in a 4. The purpose of the machine, of the function, its function is to multiply and then add. Negative 1.5 by 2 is how much? Negative 3 plus 4 is 1. Negative 1.5 by 3. Negative 4.5 plus 4 is negative 0.5. And then you start seeing the pattern, right? It's just going down by that 1.5 every time because that's its rate. So down another 1.5. So the stuff in the middle here, this is the work. This is showing you how we're doing it. But the shorthand version of this is the function of 1 is 2.5. The function of 2 is 1. The function of 3 is negative 0.5. The function of 4 is 2. Negative. So the green stuff is the only thing you need to write. The yellow and blue is how I got there. Yes, sir.
So X basically means.
The function of, the purpose
So
of.
you okay.
You still write it.
So you get the equation working, but then you just don't have to use the equation. And solve it.
It's the purpose of a vehicle is to transport individuals. Transport Preston. Preston goes here. Transport Sailor. Sailor goes here. Okay? F is the name of it. It's what it's doing. And we got to get used to that notation because y'all, everything else in high school math revolves around it. Yes, ma'am.
So was the 2.5, 1, negative 2.5, and negative 2 all the range?
Those are the range. Yes, the outputs. And then same thing. Okay. G's mission is to quadruple a thing and then subtract 12. That is its purpose. Do that with those 4 numbers. Yeah, you know how to do this. This is just our tables from last week. We're just giving it a makeover. Okay, we're making it a little fancier, making it more presentable so that we can do fancier, more presentable stuff with it.
This is making no sense to me.
Which is usually where teachers just say, it's just a fancy Y, just plug in X. Plug in X. That's it.
But I know it's not completely just against Y.
For practical purposes, until you hit Algebra 2, yeah.
So, until you to Algebra 2.
I can just say it's a fancy Y.
Okay, so I'll just always take whatever the variable is in front of it.
Replace it with a Y. Yep. Hey. How about I just put this one up there, right? You got the stuff.
So we multiply or divide these?
You missed your equal sign in between. G of 1 equals this. And then you jam it in your calculator. Or mental math, whatever your jam is.
So we multiply these and then subtract
So,
these?
yeah, 4 by 1 minus 12. Okay, should have negative 8, up 8 is 0, up 8 is 8, up 8 is 16. There's your range. Okay. Plug the numbers in. That's it. It's just plug the numbers in. We just have to give it a new name, a new flair. Because later on in math, you're going to start getting what is the function of g of x minus 3, like that. Okay? If we don't know function notation now, kids come up to Algebra 2 and they have no clue what's going on. There is nothing because I don't have a rule with it yet.
Yeah, I want to solve this too.
Oh, you have to have two different rules, like f of x is x minus 3, and then there's g of x. So you plug this in here. 4x minus 12 is 4x minus 24. Now you take that, this result that I just got, and plug it into x. That was 24. Everywhere there was an x, you put that thing.
Anywhere where there's an X, you put that.
Yes. You're replacing the thing.
So it's 4x minus 27 your answer?
Yes. I said, this is many moons down the road. This is at the minimum.
I mean, I followed along for a little bit, but.
Yeah. At the minimum, this will be the beginning of your junior year.